Okay, this lesson is going to be about simplifying radicals. Alright, so simplifying radicals is what we did today, which is January 29th, and what we'll be doing tomorrow on B-Day for January 30th, 2014. Alright, so simplifying the radical, you have to put it in its simplest radical form. So normally, you used to do a square root of 53, and you'll put it in a calculator and give me some kind of decimal. I don't want that anymore. You can't give me that anymore. You have to give me the simplest radical form. So, for terms you need to know is the radicand. The radicand is the number underneath the radical, and it has no perfect square factors other than 1. The radicand cannot have any fractions, and there cannot be any square roots in the denominator. We're going to do 4 examples, and by the way, this is pretty much what your notes will look like. It's just in your spiral, okay? So our first example is going to be the square root of 275. Alright, so what you do is you make a factor tree. So the factor tree is just factors that make multiplying with equal 275. So in my example, I did 25 and 11. And 25 you can break down to 5 and 5. And you can't break down 11 any further. Now, if you see any pairs, like I have a pair of 5s, the pairs go on the outside. Whatever you're left with stays in the inside. So my final answer would be 5 square root of 11. Okay? Okay, we're going to do example 2. It's still on the same page, and this is page 8. Example 2, we're going to do the square root of 640. So I did 80 and 8. So then I have 8 and 10. 4 and 2. 2 and 2. I'm bring this 2 down. I have 2 and 5. 4 and 2. 2 and 2. And I'm bringing this other 2 down. Okay, then you look for any pairs you may have. So I have a pair of 2s here, another pair of 2s, and one more pair of 2s. So I have 3 pairs of 2s, so I'm going to have a 2 times another 2 times another 2 in the outside, and then a 5 times 2 left over for the inside. So I'm going to have 2 times 2, which is 4, 4 times 2, which is 8, and then 5 times 2, which is 10. And that would be my final answer. Okay, now let's clear this one. We're going to do another example. Example 3. Square root of 6 times the square root of 24. Oh, no. Square root of 6 times 4 square root of 24. Alright. Anything that's underneath the radical, you cannot multiply against something outside of the radical. So the 4 is the only thing that's outside the radical, so it just stays 4. And then 24 times 6 is underneath the radical, so you can multiply that together and you would get 144. Now you should know the square root of 144 without us doing the factor tree. So the square root of 144 is 12, so I would have 4 times 12 equals 48. And now we're going to do example 4. This is the one how to get rid of radicals in the denominator. Get rid of radicals in the denominator. Realize I'm writing this with my hand on my iPad, so this might not be the best handwriting, but you'll get the gist. Alright, so the problem on this one is 2 square root of 3 over square root of 15. Okay, so I'm going to use different colors so you can know That was our original problem. Alright, so to get rid of a radical at the bottom, you first multiply the top and the bottom by whatever that radical is. So then you're going to multiply straight across. So at the top, I'm going to have 2 square root of 45, because I can only multiply the 3 and the 15. And then at the bottom, I would have square root of 225. Now, if you know your perfect squares, you should know that the square root of 225 is 15. So notice all that did when you did the radical times the same exact radical was cancel the radical. Okay, so now we need to make sure that the 45 is in simplest radical form. So I'm going to use a different color again. So I have 9 and 5. And then 9 is 3 and 3. So I have a pair of 3's. So that will go on the outside. And I already had a 2 on the outside. So now I have 2 times my pair. And I'm left over with a 5 over 15. Which means I'm going to have 6 square root of 5 over 15. Now notice that these two numbers are outside the radical, so I can simplify those. I can divide both of them by 3. So 6 divided by 3 leaves me with 2 square root of 5. And 15 divided by 3 leaves me with 5 at the bottom. So that would be my final answer. Yes, that's a lot of steps, but once you learn how to do it and do it a couple of times, that's the purpose of practicing and asking questions until you get it, then this will be easy and you'll skip a lot of the steps because you'll see the pattern. Once you see the pattern, that's what makes it easier. That's why I keep telling you how to practice, practice, practice. All right, that's all for simplifying radicals.